partial fraction decomposition, and again, let's just put PFD for short, because it'll get kind of tired saying partial fraction decomposition. Now, we're only going to do 2 problems, so it won't get that bad. But basically, is partial fraction decomposition is where you take a problem that you have and you break it up into parts. It basically would be like having a motor and one of the valves going bad. And you take the motor apart, figure out which one is not firing off at the right time. Figure out if it's the piston's gone bad, or if the spark plug's bad, or something. The crank is not. Whatever it is, you're going to go back and tear this thing apart. So partial fraction decomposition kind of does that. They take a problem that you have, and they'll take an expression that you would normally expand, and they break it apart piece at a time, so you can take a look at each piece as you go along through this one. So the very first thing they're going to have you do is have you go back and the good thing is on this one is they break it up so they focus on one part, because there's all kinds of different parts you can do, and the problems that we have in the homework, they're basically set on one type of problem that you're going to do. So for these, what they're going to do for this part is they're going to have you expand. When they call these, it's a linear factor. And you can do linear factors, you can do quadratic factors where you start with x squared, which makes it a little bit tougher, so they have you look at some different things. So the good news is that with the homework that you're going through, they stick to linear factors. And basically is this, is that if you have something that's a linear factor, where that you're doing, it's x plus some constant. You got to think about y equals mx plus b. It's 2x minus 5, it's x minus 3. It's x plus or minus some number when you're basically looking through these. Is that when they have you expand these, when they talk about doing the partial fraction decomposition, what's the best way of kind of writing this out? Basically is this. Let's say you started off with x plus 3 and x minus 2. The very first thing they're going to ask you to do is not even really find the answer on these. They're just going to ask you just to expand it and just write the form of it. So they're going to tell you and then we'll kind of set this up to kind of show you what's happening here. You're going to write the form of the PFD, and they're going to tell you not to solve it, not to find the actual values on these. So basically, for one like this, is they're going to ask you just get this thing set up so you can kind of understand what's going on. Okay, and let's do this for this problem. Let's make this x minus 2 squared. Okay, now when I'm talking about the linear factors on these, this is only in the denominator. The numerator kind of has it. The numerator would be everything working together. The denominator is where we're going to take everything and break it apart one piece at a time to figure out what's going on. And basically is that every linear expression that you have in the denominator is assigned one variable that it goes with, or one value that it goes with. So when they ask you to expand this one, you've got x plus 3 that's in the denominator. And they're going to tell you, all right, for that x plus 3, we're going to have one specific value. And this is where later we'll come back and find it. And since it's the first expression, we're just going to call that value 8. Okay, we've also got an x minus 2. We're going to call that b. And now, if it goes up a power like this one does, you also have to represent every power. So then you have x minus 2 squared, and basically that value would be c. So it's assigning a value to each part of the expression as you go along through there. And so this is where you're taking one part that you have and you break it down into individual pieces so you can kind of see how each piece is working there. Mm-hmm. You could think about that as being like x minus 2 to the first, if you want to think about it that way. That if in the original back here, if this was x minus 2 to the third, you'd have to put the first, the second, and then the third power. So whatever the power is, you have to have that many of it where it's almost like you're counting up for each one of those. If it was x to the third, then it would be x minus 2 to the third with a d on top of it there. Yeah, so whatever the power is, you just keep adding letters to it as you go through there. Okay, so if they ask you just to write the form and not actually solve anything, and again, we're only talking about linear, which you're not assigning the problems this way. But they talk about quadratic problems and all these other things. This one, they just stick just to linear. And as long as it's a linear expression, there's one value that goes with each expression and each power. Because, again, if you do x minus 2 squared, it carries a little bit different weight than just x minus 2 to the first. So one value with x plus 3, one value with x minus 2 to the first, another value with x minus 2 squared. Okay. And that's, you could take any problem. And then let's say that's example 1. We could do another one just real quick, just to kind of get the idea of it here. So we put in 4x minus 3, and that was over x plus 3 squared and x minus 4 to the third. Okay, so they ask you to expand. I'm going to put it down here because I'm not around the room if I don't. You've got x plus 3, it would be to the first power. Basically, you could say that's a. B would go to x plus 3 to the second. Then you've got x minus 4, which would be to the first power. We'll assign c value to that. D would go to x minus 4 squared. And then e would go to x minus 4 to the third. And if they ask you just to write out the form of it, and they'll tell you, don't solve for the values, but if they say just write out the basic format, that's it. That's all you got to do. I think there's one or two of those where they just kind of get you through the setup on these. And again, the good thing is that they only do the linear factors. If you bump this thing up to quadratic factors, then basically, I'll just show you real quick, your numerators then become ax plus b. That you got to have two values to go with it. This would be, cx plus d. This one would be ex, plus f, and then you would just kind of keep going from there. But they stick to linear because linear, it's a lot easier. It's just one value for each particular expression that you're working with. Gammas and betas. Go Greek. There you go, right there. Okay. So then we'll go write the PFD. And this one, they don't say anything about not finding values. So this one, they want you to actually find the values. And here's the difference, is that if they say write out the PFD and just tell you just to do that, we're going to actually go back and find out what the A, the B, the C, the D, and the E values are. So we're going to actually go back and find out what those numbers will be. Now, the good thing is it won't be anything that's that long. They're going to keep these fairly short when it comes down to it. Let's go 6x minus 11 over x minus 1 squared. Okay, so setting this one up, we're going to do, first value. Let's, if it's A, that's going to be over x minus 1. B would be over x minus 1 squared. Okay, so that's the kickoff. That's where we're going. Where again, this would be just basically the same thing as the first one. We're just going to expand this. To actually solve it and get the values, what you're going to do next is you're going to multiply by your least common denominator, which basically is going to be the original fraction. So no shock or surprise on these is that when they tell you to multiply by the least common denominator, it's basically going to be that original denominator that you started with. So for us, that's going to be the x minus 1 squared. Okay, and by doing that part, now again, when you do that, you've got to multiply every single term up here by x minus 1 squared. Okay, and here's the whole purpose of doing that when you go through these problems, is that by multiplying by the least common denominator, you should get rid of all the denominators, that you have only whole numbers in the expression, or anything that's in the numerator. Sorry, you all have any numerators. So you've got x minus 1 squared, that's going to cancel this x minus 1 squared, and leave you with 6x minus 11. On this part. Now, only one of these is going to cancel because you've got basically x minus 1 to the first, so you can get rid of this one but only knock this down 1 power. So you're going to be left with an a and then an x minus 1. Now, and usually, just by how this is set up, usually it's better to put this ABC value, put it first, and then you put the x minus 1s or where the number is behind it. It just makes things work out a little bit better. For this one, you've got x minus 1 squared and x minus 1 squared. That whole thing goes away, which leaves you with the b value. Okay, and go ahead and do the low distributed property, which is not a whole lot here. If you've got a times x and then a times negative 1, so that's just a minus a. Okay, now here's where they start making you, depending on the complexity of the problems, here's where they kind of have you go back and start setting these up where it's solved like a system. But for the problems, as long as we're sticking with linear and the problems they're going to give you, it should match up a little bit easier than that, because once you get to here, then you just start comparing. Well, on this side we've got 6x. The only value over here that's got is an ax. So if this is an equation that's going to balance out, the 6x has to equal ax because the x values have to balance each other out, which means then that a has to equal 6. And somebody may be saying, well, is that the same thing true for these? That you got negative 11, which is just a constant. Does that have to be the same as these two constants? Yes. So this negative 11 that's on the left has to be the same as these two constants that's on the right side. And from this one, knowing that the a value is 6, well, we can plug that 6 in here to then solve for b. So then if we add the 6 back over here, the value would be 5. Okay. And that's basically what partial fraction decomposition does. Is again, it takes it and breaks it down by one value at a time, so that you can go back and kind of pull the parts. Now, the way they're going to want the final answer on this one is that once you get these A and B, and if you happen to get a C value, you're going to take those numbers and actually go back to this expression you got here and plug in the A value here and then the B value here. So your final answer should be 6 over x minus 1 plus, I was going to say, you can do a plus, but probably, better to put that as a minus. So you can do plus -5, and that may be one of those where if you do a plus and a -5, it may count it wrong, which, again, technically would be correct, but we'll go -5 over x minus 1 squared.